Hello and welcome. I'm Shadow of Shadow Gaming for bringing you Programming with Shadow, episode number 40. In today's video, we're going to continue cleanup and see about writing some tests. So, we left off last time, we moved arrival and departures into the registration area where it makes sense. I think we may make a little more adjustments to those today. Looking at it more, I think there's two parts here. There's the actual arriving in the line, so picking your line, and then the second part here is actually doing the handling for it. The handling for it, I think, makes more sense to be inside the registration window. I want to think about that, but we may pull those into the registration window rather than the registration area. Also thinking that we should do the handle arrival and handle departures. I think they should be inside as well. Yeah, they're used here one time. We'll see, but I think that's the way we're going to go. First off, let's start here with setup. Setup no longer does anything, so we're going to just grab the methods out of it. Delete setup. Up here where setup was, we're just going to paste what we had. So setup's no longer all that interesting. Okay. So first off, last time I said I wanted to move this into the registration area as well. Let's see what we used it for. We're using it to print which one's the long. Okay. So let's see. Longest queue. Let's make sure there's no other uses, but I think that's it. One. So we set up there. Creator. There's where its value set, and there's where it's used. So yeah, I think we can do that. So let's see. So let's come up here. So public uint longest queue count get private set equals 0. So we'll start at 0. That handles this line. That handles this. Let's see. Set. I still think it makes sense to do this set like that. So it's just yeah. Let's move the private uint longest queue count equals 0. To initialize that. So now we don't need to initialize it here. What we instead need to do is do a get where it does the same thing. Private set where it does the same thing. If value is greater than the longest queue count, then longest queue count gets the value. What am I doing wrong here? Doesn't need that. Did it need that? Wait a minute. Oh, get. Move this so it's actually a shot. This saying I can't use private? There. Okay, there's what we want. I don't know why it wasn't wanting to update, but there we go. There, we moved that. It's got 8 references. It's a little suspicious. Let's see what breaks. So now when we handle the departure, we need the fine long. No, we do not. We can update that. Where was that method? Here. So let's look. Let's see. When we do an arrival, let's just do this. If longest queue count get window.count event. Negative, so we can just save cast. So there. So now we set that every time. So since we have since we did the setter here, it'll do the check there and it'll only set it if count's greater. I think that's all we want to do there. Because departing won't make the queue any longer, so I think that's right. That means we can get rid of this. On display simulate. Okay. It's just a UNT, so it's just a count. So we should be able to just say registration area dot longest queue count. There we go. Control C this. This just becomes registration area dot longest count. With that, we have the refactoring. That now it's done over here instead of over on the side. Let's see what happens. That one. Where's the other one? But yeah, let's just look at how this works and see if we got the refactor right. There. Wasn't wanting to accept my buttons. No, we did not. Okay. Alright, so let's see. Here, I'm just going to undo just a second. Let's make sure that that was the problem. Just make sure this works. Okay, this works. So undoing this did not. So if we go forward now. Longest queue. This does not work. That looks like it works. Alright, so the other one, need to take a little closer look. That looks like it's working to me. Really, whoops. Yeah, I believe that worked alright. Let's check that other one. Let's see what it actually. Longest line count. Let's put a breakpoint here. So F9. Let's just compare. So test equals registration area dot SQ. I think should be the same thing with the breakpoint there instead. Let's see what happens. There, longest line is 1, test is 1. Let's go to the locals, see the local values. So longest line and test. 2 and test did not update. Okay. So let's see. So if test ever updates. Okay, so test is not updating, so that means their longest key. What I was trying to do is just add it whenever we add one. Probably should be in that method to begin with. Find in queue. Oh, wait a minute. I guess that doesn't work. Whenever we in queue, I want to check the count again. I think that should do it. What I'm trying to say is that when the window grab it, you add something to it, and then you check the count, and if the count's bigger, you set it. I think that's what this does. Put a breakpoint here, and let's step into this. Whatever button I just pressed. F9. Let's see. Longest queue count is 1. Window count is 4. Longest queue count is 4. Oh, it needed to be before the 0. Let's see if that doesn't fix it. Wait a minute. Now let's comment that line out, and we'll make this to be longest line. Yeah, so what's happening there is if the position is not the first position, we don't count it. So it does need to be there. Remove that. Now we are counting. Okay, there we go. Fix that. Easy debugging at least. Go ahead and stop. Let's do the cleanup. Remove that. Now this is unused, so we can move this. We'll press there, but control dot. Replace with property. Remove unused memory. There we go. Where else? Remove this line. I'm going to remove this one as well. Remove this. And remove this. So there we go. Little more moved over. Let's see. I still want to come back to these twos, but I don't think they're right now. As I said, I think I want to pull this logic to this. Let's try it. Let's see. Yeah, let's try this. Let's do what does it return? Doesn't return. Yeah, they're both void. Okay, let's do it like this. Public void handle event. Get in a event current. So here, if current.event type is arrival, we do handle arrival. And I'm betting these are going to look just like the other ones. In fact, I can just copy these. Else throw new exception. This is an invalid operation at this level. Invalid event current. No. All right, so let's go remind myself what this does. Okay, they don't do a whole lot actually. Okay, they're just adding to the queue. Okay, so there's what it needs to return. It needs to return the next event or null. So we'll say event null. We'll do it like this. So now let's do the private void handle arrival event arrival event. And here we'll do private void handle departure event departure event. All right, so now we can just call these methods here. So handle arrival, passing in current, that. Handle departure, passing in current, just like that. These are returning an event or null. Event or null. Return null. Return null. Now these are just returns. Let me spell that one. Okay. So right here, this could probably be a switch expression. I know what I'm hitting there. I'm hitting Alt Enter. So on Rider, that would be what you actually press to get your hints. In Visual Studio, it's Control Dot. Here it wants me to invert if. That's not what I do. Thinking I probably can make this into a switch expression. I'm not sure. We can think about that because it would be something like current dot event type switch fit. Add cases. Rows this. these instead of throw are handle departure, no, handle arrival, current, handle departure. There, I think that will actually work. Now it's the same thing as we were doing here. I would argue it's slightly cleaner, at least to read, which is nice. I'm going to switch it to that. Now let's fill out these methods. All right, so let's see. So all we need to do for arrival is we need to create a registrant equals new arrival event.id, arrival event, event, departure, event equals arrival, passing in the registrant, then return departure event. So we could even do that on one line if we wanted to, but I'm going to leave it separate because I think I'm going to want to do. Let's see. We'll see. So here, same thing. Int registrant ID equals departure event dot registrant ID. That's not even necessary. So instead, we'll just do event next event equals departure departure event dot ID, and we'll return next event. And I think that covers the handling for both of those. I believe. Now what we can do, comment these out. Okay, Control C. Up here where it fails, now we'll do var next event equals registration area dot handle event, passing in current. Now we still need to do if here, but now it's easier. Now if next event is null, is not null, now we do, what was it, schedule next event. And I believe if we go look at this, I believe this is a nothing. Yeah. Let's grab that here and say that. I believe at this point, I put a semicolon. I believe we have that build, and I believe if I look at this, I believe we can Control C. Now I believe we've abstracted that logic out as well. Oh, there's a build error. Let's fix that first. Look at over here. See a semicolon. Yeah, I've got an extra. Okay. Now let's try that. Builds. Does it seem to work? All right, so there's pulling more of the logic that doesn't matter into where it doesn't matter to the registration simulation, but matters to the registration area. I think that makes sense. The registration area handles the event. I do think the events still need to be created by the convention center. Convention registrations where the events are come from, and then they're handled in the area. I think that makes sense. So we'll go ahead and clean that up then. Clean all this up. And already cleaned it. Okay. We can clean that up, it no longer matters. Let's see if we can extract this into a little local method. The refactoring list. File people while registrants are still in line. Move that out to that. While registrants are still in line, we get a person off we get the event, increase the processing. Yeah, and then we handle the event. We add the next event if it exists. We display the simulation, and then here we slow it. Yeah, I think that clears this bit. Move this. Move this up. So not a lot of difference there, but we'll move it up ahead of that. Here, this comment no longer necessary. There, I think we've done a little bit more cleanup there. I think generate arrival events, I think it makes sense to be here. I think displaying the final results makes sense. I think displaying the simulation makes sense, minus still question this one. Yeah. Now I think we've pretty much moved out what I wanted to move out here. With the convention registration, it handles opening, handles the display, has a registration area, has the queue. Date time, open time, all the defaults, expected number. Yeah, so now I think it much more closely does what we wanted to. Events problem. Yeah, it's just keeping an event count of events. Yeah, I believe that does what I want it to do. All right, so let's take a little closer look at the registration area. Where are we using this? We're still using it, so maybe we're not using count, so count can go away. Let's see, the rest of this makes sense. So registration area handles the event. So the events are arrival and departure. So I think that makes sense. So the handle arrival. Yeah, there's nothing Windows context there. It's all events. Let's check the arrival. This is where the window gets handled. Right now we're just calling the enqueue. Yeah, this not make sense. So we count the arrivals. I think that still makes sense to here. Get the shortest line, so we need the registration area for all the lines. Get the window of the shortest. We enqueue, get its count. Mess around with the count. Yeah, I don't think any of that makes sense to be in the window, actually, looking at it now. I think same thing for departure, so find the window index. What are we finding? We're finding which registrant, which window has the registrant. That could probably be moved inside, actually. Peak's only using the first position. Okay. So it's checking the first person in each list. So yeah, so let's take a look at that. UDQ peak. Peak makes sense. It's checking the first. So I think that's fine. But we could abstract it out a little bit and do it more. I'm not liking this. So whenever you have that, that means you end up with tests that look like where's the peak? You end up having tests that have more setup than you usually need. Let's evaluate where we use peak. So 6 times. This is the only spot. Right? Oh, 2 spots. Doing. Okay, they're both internal. Where's this one used? Also internal. I feel like I can do that better. So let's take a look at that method next. So here, let's do in the window, let's say what we're actually looking for let's see. For this one we're looking for registrant, this one we're looking for ID. So maybe not, maybe this is as good as we want to do. Yeah, all this is doing is grabbing the first one. Where was that used? Get the next one. Maybe I do want to keep that actually. That I think that does make sense for the usage. So get the first person in line. I think that does make. Maybe then I don't want to actually here, and I don't have to test something separate. Yeah, maybe scratch that idea. Yeah, yeah, maybe not. So schedule. Let's make sure it. Yeah. So what I would be doing there, I'm basically moving the peak. Like, yeah. So this one's okay. So let's do a public full first does first registrant ID match. We'll pass in int registrant ID. So here, all we need to do is we need to do a return peak equals registrant ID. Peak null, so do that. Split it up. If peak var first registrant peak registrant is not null. Return first registrant dot registrant ID equals to that, else return false. There. Now we can just do if window dot does first registrant ID match. It's a little longer, but I think it's a little clearer. I might could make the name better. I think that's all right though. I think I like that better. It does give us a little bigger surface area over here though. So let's write that test. So Windows tests. Put it over here. I guess let's make sure it runs, but I'm going to. Looks like it's working. Yeah, so we'll write a test for that, and we'll make sure all the current tests still work. They do. I don't think we broke anything actually because there's not that many tests. Finishes processing. Go. Wait a minute, it's not shrinking, is it? Oh, I see the problem. So what's happened there? So when I've changed this from longest queue count, what it was doing before, it's getting the current longest. Let's see. Let me open a program here. So while that's opening, we'll see. So so that's what's happening. So right now I'm getting the all-time longest. There I was not getting the all-time longest. I was getting current longest. So what we could do is we could actually add that as well. And well, I don't like that, but I think that might be all right. That makes more sense why it was a separate method instead of not using that value. That makes me check. Find longest line count. So yeah, so it's finding the current long. Do without a method for that. Let's do it. We'll do public uint find longest queue. List. Okay. So we'll start with uint longest queue equals 0 for int I equals 0, I less than number of windows plus. So if registration windows I.count is greater than the longest queue, then longest queue equals uint registration window at I.count. And then return longest queue. I think that'll fix it. So I'll tell you what we could do. Right now I'm doing this myself. What we could do is we could say longest queue equals math.max registration window at I.count versus longest queue. We'll do it ourselves since we're doing it as a uint. Maybe we don't even need to do it as a unit. Count as an let's just switch that to an int. I still think uint makes more sense from perspective, but it looks like counts an int anyway, so we'll undo that. Now this says give me the max of these two, so it's doing the exact same check here. So we can do that. There we go. That sets us up nicely for something else, though. Maybe we'll do it next time. Let me do it to do. Maybe do a link query here. So this puts us in a good spot to do that, do at least one of them, and start taking a look at link just a little bit. Let's fix the bug first. So where was the bug? Here. Dot find longest queue. Now, if we run this, expanding properly. Longest queue looks like it's working. Still building. There we go, and then it shrinks. And it stays in line. So yes, okay. So that fixed that. Okay. So I think so link is a way to do this a little more readably. So we'll talk about that next time. So we'll leave that to do here. Yeah, so now this one's become a lot longer method. I don't think it's become that much longer. So let's write a couple tests for this. First things first. Numbers. So fact public void scheme is does first registrant ID match returns false when there are no registrants. So I'm going to drop the arrange act assert, but we're going to follow that pattern. So we'll do registration window like that. There's nothing else we need. We can just say var actual equals sit dot does the match. We can just say we don't care. Then our asserts here are assert that actual is false. We'll also assert the count. Assert dot equals 0 actual. No. Assert dot count. There should be a passing test, so that tests this path. No, get rid of that. Yeah, that's no longer a method there, so I think we can close that. Close that, close that. So that functionality was moved. So we need to move those tests, but I don't think we want to do them. Let's just run all the tests first and see what happens. So that one we just wrote should have passed here, and it did. Registration windows. That's this case, so we peek. Peek was null, so we hit this false, so we check that case. Now there's two cases in here. So first, let's copy this. Now we need to do a little bit of setup. It's false when the first registrant does not match. All right, so now we need to do a little more setup. So we'll do soot.enqueue need a new registrant. We'll do an ID of const int expected ID equals 0, const int actual ID equals 42. Number doesn't really matter here. We're just putting something in. New event. It is an arrival. Date time dot now and actual ID. There. So now we've added someone to the list. Now we check, do they match? They do not match. There's one person on the account. Check expected ID. Now we get another successful test here. It succeeded. And we checked this case when it doesn't match. So now we need one more check. True. The first registrant does match. Expected is 42. So this true there. So assert that it's true and that their count is still. So we should see this one succeed. And we did. So now if we check all tests, they all ran. Everything in here now has a test again. So that's a good situation. So where we'll want to start looking at next is registration area. So we should start testing here. And like I said, there may be a little bit more cleanup I might want to do, but we're getting very close to the end of this one finally. So it's been a while. When did we? Episode 28, so episode 40. So not that bad. 12 episodes right now. So maybe by 15 we might be closing out this and ready to move on to a different topic. But we're going to call it with that. Here, let's clean this expression up here. Clean that up. This duration. All right. So for next time, we'll continue with cleanup and testing. So we're getting a lot closer now. So we've got the things starting to be a little more object oriented. Perfect timing on this video, so we'll call it there. So thanks for watching and have a wonderful day.